The segment's midpoint is the point halfway between endpoints. The two segments are congruent if they have the same length. So two pieces are equal or congruent if they have the same length. To measure a closed figure is by the total length of the boundary. We call this perimeter of the figure. Perimeter of the figure, okay? So let's try to do this example. Farmer Fred wants to fence the oddly shaped region shown in bold at the right. If each of the squares shown has sides that are 10 feet long, and the fence costs £7 or $7 per foot, how much will Fred's fence cost? So we need to, this is a fence, so we need to know how many pieces we have, the length of the fence. So we need to get the length of the fence first, because each foot costs $7, right? So how many feet we have? Each of them 10. So 10, 20, 30. So we have 50 here. 50 feet here. 50 F. And here we have another 20 F. And here we have 1, 2, 3, 4, 40 feet. And here we have 1 or 10 feet. Here we have 1, 2, 3, 4, 40 feet. Here we have 20 feet. Another 20 feet. Another 20 feet. Right? So we can say the total number of fence, the total length of the fence is 50 plus 40 plus 10 plus 40 plus 20 plus 20 plus 20, which is equal to did we miss something? We have another 20. 50, 40, we have another 20 plus 20. 1, 2, 3, 4, 5. Oh, we have another 10 here. We have another 10 here. So 10 plus 10. Because we need to get the length of the fence. So the total is 240 feet. So this is the length of the fence, right? But the goal is to get the cost. So the cost is 240 times how much? $7 per foot. $7 per foot. And we have 240 foot. So we got $1,680. The cost of the fence. Right. Important. Opposite sides of a rectangle are congruent, correct? Because why? This side is equal to this side. And this side is equal to this side, right? So to find the perimeter of this, L plus L plus W, which is 2 times L plus W, the perimeter. A triangle is called equilateral if all of its sides have the same length. This is important. This is one type of the triangle. We call it equilateral if all sides are equal. In this diagram, all 3 triangles are equivalent, are equilateral, sorry. Point D is the midpoint of AC. G is the midpoint of AE. If AB is 4, so this is 4. Because this is equilateral, so BC is 4, AC is 4. Since the triangle ABC is equilateral, then the segment AB is equal to AC is equal to BC. Because we know one of them is 4, so all of them is going to be 4, right? So all of them, these guys equals 4. Be right here. 4. Since D is a midpoint of AC, then AD is equal to DC, right? So this from here to here is equal to this segment. So this is 2, this is 2, which is 2 here. And since the triangle ADE is also equilateral, then AD is equal to AE is equal to DE, which is 2, because we know one of them is 2, so all of them are 2s, right? Are you following or no? Seems that I'm just explaining to myself. All of them are 2. The last triangle, again, hence G is a midpoint of AE, then AG is equal to A to GE, which is what? 1. Because this is 2, so this is 1 and 1. For the same reason, since the triangle, last one, the small one, GFE is equilateral, then GE equals GF equals EF equals 1. So we have 4, 4, 4, we have 2, 2, 2, and we have 1, 1, 1. So the question says find the perimeter of all of this guy. The perimeter is just the summation of all of them. So as a result, the perimeter of A, B, C, D, E, F, G is what? The summation is what? is AB plus BC plus AC plus AD plus AE plus DE plus GE plus GF plus EF, which is equal to what? 4 times 3 plus 2 times 3 plus 1 times 3, or we can say 4 plus 2 plus 1, all of them times 3, which is what? 7 times 3, 21 units. We can just say 4, 2, 1 times 3. We just add the sign times 3 because there are 3 of them. Question. Okay. Points B and C are on a segment AD. So let's graph the segment AD. So BC somewhere. Okay. BC is 6, so this is 6. AC to CD, AC to CD is 3 to 1. And B is the midpoint of AC. So this one equals this one. So this is also a 6 because it's a midpoint. So since B is midpoint of AC, then AB is equal to AC, which equals to 6. Right? So the goal is to find the length of AD, the whole thing. So now we have AC. AC is 12. So AC equals AB plus BC. 6 plus 6 equals 12. Right? But what we know, the relation between AC and CD is a 3 to 1. So AC to CD is a 3 to 1. So if AC is a 12, so again, it's AC to CD is a 3 to 1. If this is a 12, what this one is going to be is going to be 4. It's like you multiply by 4, right? So now AC is a 12, then CD equals 4. So this is 4. So what is the length of AD? 12 plus 4, which is 16. So AD equals AC plus CD, which is 12 plus 4, 16. Right? Because we are given this fact, actually. AC is a 3 to 1. AC to CD is a 3 to 1. If AC is a 12, how to make this 12? How to make this number 12? Why multiply by 4, right? Multiply by 4, you get 12. So multiply by 4, you get 4. Right? So AC is 12, CD is 4, so the total is going to be 16. Make sense? Good. Let's go over some concepts. Triangle is called isosceles. Isosceles if what? Two of the sides are congruent. So if you have a triangle and two sides are equal, then this triangle, we call it isosceles. Okay. So in this problem, it says two congruent sides, we call them legs. The two congruent sides, we call them legs of the triangle. What about the other side? The other side, we call it base. Let me try to triangle. Maybe this is kind of isosceles. These are BC and AC are the legs, and the base could be AB. So these are clearer than before. So AC and BC, if they are equal, these are the legs, and the base is AB. So this is isosceles triangle. Suppose an isosceles triangle. So let's just to graph this. Isosceles, something like this. Okay. This is isosceles. Let's give it a name. A, B, C. The perimeter is 45. What is the perimeter? Perimeter is the summation of all sides. So AB plus BC plus AC is 45. Let's do this. Because these are equal, let me call this X and X. This will be called Y, okay? Because isosceles, AB is equal to AC. So X plus Y equals 45. So 2X plus Y is equal to 45. This is the first fact. The length of each leg is twice the length of the base. So this is double than this. So basically, let me do this. Let me erase this. X and X. Okay, let me delete them first. And use this fact. So we have home here. The length of each leg is twice the length of the base. So if the base length is x, this is going to be 2x. That makes sense. Okay. If the base is x, then the legs is going to be the double of the base, so 2x's. Now we can say, okay, AB is 2x, BC is x, AC is 2x. Then we have 5x equals 45. Then x is 9. So the length of the base is 9. So the base is 9. What about the legs? Leg is 2 times 9 is 18. Right? Okay. You have a triangle where the two sides are, or no sides are equal, so we call it scalene. If the sides are different, so you have 3 types of triangles. You have the equilateral triangle where all of the sides are equal, isosceles triangle, and scalene triangle. Who can tell me what are the three types of the triangle? Yeah, who can tell me? What are the 3 types of a triangle? So you pay 0 attention today.
Isosceles, scalene, and right.
No. Equilateral, isosceles, scalene. This is in terms of the sides. If you talk about in terms of the angles, so they're going to be right, obtuse, acute. But today we are discussing equilateral, scalene, isosceles. But you guys today you're playing around and doing nothing. Okay. Mary leaves home and walks 7 miles in one direction before stopping for lunch. Jeff leaves from the same home. So let me grab it. So Mary leaves home. Suppose this is Mary's place. Seven miles in one direction before she stops for lunch. So suppose that she goes this way. She stops here for lunch. Jeff leaves from the same home and walks 4 miles before stopping for lunch. Now this is Mary. Here is Mary. Mary is here. Okay. Jeff leaves from home, the same home, and walks 4 miles before stopping for lunch. So we don't know basically which direction did he move. So let's do some assumptions, okay? Suppose that he went this way. This is 4. And he stops here. Lunch. This is Jack. This is 7. This is 4. Is it possible for Mary and Jeff to have lunch 12 miles apart? So the question is, can the distance between this and this be 12 miles or no? Can the distance be 12 miles or no? So this is the question. I'm waiting to hear answers. Can this be 12 miles or no? Mary moves from home. After 7 miles, she stops for lunch. Jeff went for lunch. We don't know which direction, so I assume that he went this direction. After 4 miles, he stopped for lunch. Can the distance between Jeff and Mary be 12 miles apart? Is it possible for them? Why? Why, Sarah?
That's not possible because like if if the point where Mary and Jeff live, like and Mary walks one direction, unless Luke went unless Jeff went exactly the opposite direction. Exactly
Okay.
the opposite direction he could.
What did you say about if he went the opposite direction, what's going to happen?
They're going to be 11 miles apart.
So which is what? This is what?
It's smaller than 12, so it's not possible for them to be 12 miles apart.
Yeah, I mean, as Sarah said, thank you, Sarah. At least someone talked to me today. So it is the farthest, right? So this is the farthest it can be. It is just 11 because the worst, I mean, the farthest they can do is Jeff going to the opposite side. Going to the opposite side. If he went to this side, this direction, sorry, this is 4 miles. So they are going to be 11, basically. 11 miles apart. And this is the farthest. But any other direction that Jeff is going to take is going to be shorter, simply. Because these 2 points, they're getting closer to each other. For any other direction. So for sure, it's going to be less than 11, in fact. So yes, to answer this question, no. Why? Because we just explained why. Is it possible for a triangle to have side 4, 7, 12? Also no. Yes, because for the same reason. For the same reason. Otherwise, it's not going to have a triangle, actually. So 4, 7, 12 cannot happen, right? Because the maximum distance between the 2 points is going to be 11. So basically, to form a triangle, so that means this point is going to be somewhere here. So the distance between these 2 points must be less than 11. Less than 11, not 12. So again, the answer is no. This triangle, this cannot be 12. For C, suppose, again, this is no for B, for the same reason we mentioned. Suppose a triangle has the sides A, B, C. So let's have a triangle. Suppose this is A, B, C. Is it possible for A plus B to be less than C? Is it possible for A plus B to equal C? For the same reason, again. For the same reason, we mentioned this. A plus B has to be less than the third side, right? We do have a triangle or greater than the third side. Right? Can be equal? No, they cannot, because we mentioned the case of Jeff and what do you call it? Mary. This is home. If this is A and this is B and this is C, this is the only case where A plus B can equal to C, or A plus C could be equal to B. Is the only way where A plus B could be equal to C, straight line. So it's not going to be valid for the triangle. Triangle cannot happen, right? Cannot happen. So you have a summation of two sides. The third one cannot be greater than it, as we had for 4, 7, 12. Should be less than them. So A plus B, right, should be less than C. Okay. You remember before we had 4 and 7. You add them, you get 11. So this guy, 12 is greater than this guy, so cannot happen, right? Okay. Triangle inequality says you have 3 points of the triangle. Let's say this triangle. So we said this is not going to happen. It is not possible. Okay, just to make sure that not possible. As we have here before, should be greater than. Summation has to be greater than third one. Summation has to be greater than. Suppose that you have A, B, C. So AB plus BC greater than or equal to the third one. If they are equal, so they have in the straight line. They are, yeah, correct, greater than. Just messed up things here. It's not possible to be less than C, yeah. Because you're not talking, I'm getting sleepy and I'm losing I'm losing my focus. I'm losing my focus. Yeah. So AB plus BC greater than or equal AC. They could be equal, but this is going to happen if they all lie on this, straight line. So if they're equal, that means B is on AC. This is AC. This is B. So this AB plus BC is going to be equals to AC. Otherwise, the summation of two sides, they have to be bigger than the third one, right? Triangle inequality. The area. In the triangle PQRS, we have PQ4, QR9. What is the area of the triangle? Okay, you have, let me go there. This is diagonal. The diagonal divide the rectangle into two equal triangles. So what is the area first of the rectangle? Rectangle PQRS. It's 4 times 9. W times L, right? W times L. Length times whatever. So this is 36. This is the area of the rectangle. But we need to know the area of the PQR, this guy. So the area of the triangle is equal to 4 times 9 times half, or divided by 2, which is 18. 18, right? Because the diagonal divide the rectangle into two equal triangles. Okay. The legs of the right triangle are the sides of the triangle that forms right angle. We call them legs. These are legs. A and B are legs. Suppose the legs have length AB. Find the formula for the area of the triangle in terms of AB. Yes, basically If you have rectangle, and this is A, this is B, we know that this is right angle, right? We know the area of the rectangle is equal to A times B. So the area of the triangle here is going to be half of the AB. So that's why we come up with the formula. The formula of the area of the triangle is just half times the two legs. If you have right-angled triangle. And the two legs, they form 90 degrees. This is very important. Ravi and Ranu are trying to decide how to paint a rectangular wall that is 18 feet long and 8 feet high. Ravi wants to paint a right triangle, as shown on the left. Ranu wants to paint more interesting triangle, like the one shown in the right. What is the area that Ravi wants to paint? Okay, this is interesting because we know this is 18 and feet. This is 8 feet. Because these are rectangles, so this is 90 degrees. Because this is triangle, we know the area of the triangle, we just shown that, is the product of the area of triangle is what? Half times the two legs. 18 times 8 is 72 square feet. This is for Ravi. This is Ravi's work. Ravi's triangle. Ranu's triangle, we need to work on it because it's not clear what's happening. So what we're going to do, we're going to divide this again into two parts. This is the first part. So this is 90 degrees. Now we are going to find the area, the gray area of the triangle of the right-hand side and the gray area of the triangle of the left-hand side. So we know that this is 8. We know that this is 18. Right? So this is 8, this is 8. Do you agree? Good. So we can think about this in different ways. We can say the round is a triangle. We have two triangles now. The first one, you can call this one, we can say, I don't know, you can do it in a different way. The round triangle, let me delete them. Yeah. Let's say, let me call these A, B, C. Make sense? Okay. Then let's try to think about the two triangles now. So what is the area of the triangle, the area of ADC is equal to the area the triangle, the small one of the triangle. Let me write the triangle. CBD plus the area of the triangle ABD, right? And we use the formula that we know. So what is the area of CBD is this guy times this guy times half. So half times CB times DB plus the area of the other triangle is half times AB times DB, right? So let's pull the half and DP as a common factor. Let's pull them. So let's pull half DB out. What is left? CB plus AB. CB plus AB. What is CB plus AB? The whole thing. So this is equal to half times DB times AC. So this is AC actually. Now, do we know this information? Yes, we know. DB is 8. AC is 18. So the answer is 72 feet, square feet. So we got the same answer, basically. We got the same answer. We got the same answer. Again, these are, sorry, these are, okay. So this is the divide the wall with the Ranus. This is what we did exactly with Ranus. Sometimes if you don't know the area, we break them down to pieces. So how to find the area? I mean, this is exactly what we did before. To find the area of the acute triangle. Let's have this triangle. This is acute. So let's call it A, B, C. So let's figure out how we are going to find the area. First of all, we will do the same thing. We will, divide this into two triangles by having right-angled triangle. Because look, the idea is we started Y. I mean, how did we come up with the area? The area is the product of the two legs times half, period. That's it. The area is the product of the two legs times half. So we need to create legs here. Now we created legs. So we can say the area of ABC is equal to the area of, this is D, okay? BCD plus the area of ACD. What is the area of DCB? The legs. The legs times half. The legs, product of the legs times half. The other one, the product of the legs times half. We will do the same thing. We will pull this out. Pull this out. DC is the same as CD. So half is going to go out. DC is going to go out. Then we have BD plus AD. But BD and AD is all is everything. AB is AB. Okay. So this is the area. What is the area? The area is half times one side times the perpendicular that comes from the other vertex. So this is the way where the base and height have been created for the triangle. The idea of the base and the height has created from here. Now we can talk about the altitude or the height and the base. This triangle, if you do it in different way, if you, for example, erase this guy and you divide the triangle into two triangles by having, you know, right angled from here, you will come up with the same thing. So the point is, in every triangle, we have three sides, and these sides, everyone is a candidate to be a base. And every base has his own height or altitude. Every base has a height. We will be coming and talking about this. So to find the area of the acute triangle, we select one side to be the base. The perpendicular segment from the vertex opposite to the base is the altitude to the base, as we did. For example, this triangle, this is my base, this is the altitude. So the area is AD times base C over 2. The altitude, we call it height. Okay. Now, let's look at this lovely triangle. I will do different shading. This base has this height. However, this base has this height. And this base has this height. We can find the area in different ways. All of these are correct. Okay. All of these are correct. These three lines. So in each triangle, first, let's read this, has three heights, one for each base, as we said. The three lines, they share a common point, which is the concurrent, right? And this point, when they meet, we call it orthocenter of the triangle, which is the common point in the middle. If these are the heights, then this is true. Okay. Now, Ravi and Ranu are expanding their house so that the wall that was 18 by 8 feet will become 20 feet by 8. Okay? Ravi still wants a triangle that reaches from one corner to the opposite corner, but he doesn't want to use any more paint than he used for his triangle on the old wall, right? Ranu says they will just keep the bottom of the triangle the same and extend the top to the new corner as shown below. So before they had this 18, then they had something like this. Then what did they do? They want to extend, so they pull this here. So this is not going to be here anymore, because they're going to extend from 18 to 25, right? Do you agree? So let's call this triangle ABC. Let's call this guy D, because we need this. It's clear that we have a big rectangle and we have 3 triangles. Our goal is to find the area of the shaded triangle. So we can think about this. We can say, okay, we know the area of the rectangle by multiplying 25 times 8. We get the area of the rectangle. What if we find the area of this triangle and find the area of this triangle? Then we have the area of the rectangle, the big area. Then we subtract these 2 areas to get this one. So this is the plan. To find the area of the ABC, it will be very easy to find the area of the rectangle first. So let's find the area of rectangle, which is 25 times 8, right? Which is 200 square feet, right? Question? The area of, let's say this is F. AFC is equal to 25 times 8 times half, which is 100 square feet. The area of ADB is what? Is 8 times 7 times half. Why 7? Because this is 25, this is 18, this is 7. This is right angle triangle. This is right angle triangle. So what do we get here? This is 28. square feet. Right? So what is the area of the shaded, triangle is what? The 200 minus the 100 plus 28. The area of the whole thing. Right? Even sometimes, even there is no need to find the area of the rectangle because we know this is half anyways. This is, what do you call it? Diagonal. So there is no need to do this. So this is 72. This is one way we have, we have many ways to do it. You can just find the area of this minus the area of this. 100 minus 28. That's it. 100 minus 28, you get 72. So this also will be working. Okay. To find the area of the triangle, we select one side to be the base. This is important. The perpendicular segment is going to be the height. Okay. A median of a triangle is a segment that connects the vertex of the triangle to the midpoint of the opposite side. For example, in the diagram on the right, AM is a median of ABC. Show that the median divides the triangle into two pieces of equal triangles. So this is clear because look, what is the area of the triangle AMC? If you make height or this, if you choose this one to be the base, so this is AD. AD is going to be the height. If you choose MC to be the base, AD is going to be the height. So the answer is this is half times the base, which is MC, times the height, which is AD. The same thing if you choose the base of the other triangle. Now we're talking about the other triangle, area of the triangle AMB. If you choose the base to be this guy in the green, MB, then where is the height? This is the height. It's AD as well. And these are equal. These are equal. Because MC is equal to MC is equal to MB. These are equal already. So number one is equal to number two. That's it. So the median divide the triangle into two pieces with equal triangles. With equal areas, sorry, equal areas. Okay, Because you did nothing today, answer this question on the chat box. I'll give you 5 minutes or 7 minutes. Answer this question and give me the answer on the chat box. Send me the answer to where? To the host. To the host. Give me the breakdown of the solution. You send me the solution. How did you do it? The breakdown of the solution. The goal is to get the area, okay? The area. So we need to divide this shape into many shapes, okay? And each one of them has a 5 feet as a length. You may multiply by 5 at the end, but we're looking for the area, not for the, what do you call it? The perimeter area, okay? Divide this into shapes, rectangles and triangles, and find the area, okay? We can't do this, no. We need to divide this big shape into rectangles, triangles, then use the formulas. The area is half times base times height, or base times height if you have rectangle, width times length. Okay. Okay. I'll give you a hint. Okay, I'll give you just a hint now. You can, for example, do this. This is this triangle. This is rectangle. So find the area of this, the area of this, then divide the others as well. Oh, I'm getting too sleepy. Any ideas? So let me do this division. If you have irregular shape, it's a good idea to divide this into something you know, shapes you know. So what we know is rectangles and the triangles. So I'm going to divide this like this. This is right angle. So we have rectangle and the triangle so far. And this is a really good, nice rectangle, the big one. And we can say this is triangle. Okay. And this is rectangle, this is triangle. So I divided this guy into 1, 2, 3, 4, 5, 6 areas. 6 areas. Now each of them is 5 feet. Now we have rectangles. Rectangles, we know that we got one answer from Cafe, so let me check, okay? The triangles, this is right angle to triangle. And we know that the area is half times base times height. We have 3 triangles and 3 rectangles. Rectangles, we have no problem because, so let me call them, this area 1, 2, 3, 4, 5, 6. So let's find area number 1. The area is, number 1, the area of 1 equals, because this is rectangle, is the width times the height. How many pieces we have? 1, 2, 3, 4. 1, 2, 3, 4, 5 times 2. 5 times 2 times 5, because we have every square is 5 feet length, okay? So we got 10, 50. This is 50. 50 feet squared. So the first one is 50, right? Yes. Good. Number 2, the area of 2. This is, we need to look at the base. So it's half base times height. Half, the base is a 3 times 2 times the 5, because each of them is 5. So this is going to be 15. Right? 3 times 2. Number 3, area 3 equals 1, 2, 3, 4, 5, 6, 7, 8. 8 times 2 times 5, because each side has a length of 5. Right? Hold on. 1, 2, 3, 4, 5. Sorry, by 25 here. I'm so sorry. This is 25. Each of them is 5. So this is 25. This is 25 here. This is times 25. This is times 25. So here we got 250. 250, right? This is 75. Now this is going to be 400. Now area 4 is rectangle. So 1, 2, 3, 4. 4 times 2 times 25. Why times 25? Because everyone is 5 by 5. So this is going to be 200. Right? Okay, I like your way, but how do you do the minus how many shapes? We have one shape at the top. Yeah, good idea. Good idea. And oh, it's gonna be difficult. It's gonna be the same thing anyway, because the shape at the bottom is gonna be divided into many anyway. Now area 4, we did 4, 5, area 5 now. Area 5 is equal to 1, 2, 3, 4 times 2 times 25 times half, which is 100 feet. Area 6, it's a rectangle again. 1, 2, 3, 4, 4 times 1 times 25 times half, which is 50. I got Sarah says 1075. Let's see. So all of the areas, let's add them. The first one, I got 250. Second one, I got 75. Third one, I got 400. This is 200. This is 100. This is 50. So what is the total? So this is 5. 1075. So the total is 1075. Correct. Okay, we got the same answer. This is not the only way we can divide this. You can divide it into different ways. The way that Kafli did, she said, okay, sometimes it's going to be easy if you calculate the area of the whole thing minus the areas, the outside. That's fine as well. But still, you need to construct. You need to construct some of the stuff here. Look at this. I don't know how to divide. How did you divide it, Kafli? But let me tell you something. For example, here, look at this guy. This guy, this is 1, right? This is 2. This is 3. This is 4. Makes sense as well. So the total area, how many is the total? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So we got 7. 8 times 25 is the total minus these guys. This different way. 3 times 2. This is 3 times 2 times 25 over 2. rectangle, triangle, sorry. This one, 2 times 1, 2, 3, 4 times 25 over 2. This one, 1, 2, 3, 4, 4 times 5 times 1 times 5. Okay. And this one is 1 times 3 times 5 over 2. Anyway, you should get the same answer. You got it wrong because the way that you divide it maybe is not necessarily right. So take care of the, dividing this into a good way. So maybe some students, they may divide this in different ways. So maybe, I don't know, this is here 1, this is 2. Yeah, I mean, this is the way that we did it could be the best. This and this. Yeah, and each of these 5, 5, 5, 5, 5, 5, 5. Okay. So the way we did it is maybe the best way. Anyway, so we have many methods to do this. So you can split in different ways. I'm going to post the exam, midterm exam, okay, by tomorrow. So, plus the homework that you're going to do, the homework, there's an exam. It's for you, I mean, home exam, okay? Take home exam. We just go over the definitions and we stop. We still have 5 minutes. What is the circle? The circle consists of all points that are fixed distance, called the radius, from the given point called the center. So this is the circle. So look at the point here is the center, and all of the points on the circle have a fixed distance of this point. All of the points, this distance is fixed. So this is the definition of the circle.